so polar equations, this is going to allow us to be able to draw those flowers and spirals and all kinds of different graphs because it allows us to go around a circle. Of course, they're not functions because they would fail the vertical line test, but these are pretty cool how they turn out. Every little detail we use today to solve these problems you have done before. You have not done this before, but you've done every step that we're going to do today. Okay. So polar equations. Your new ordered pair is r theta. No, you are not drawing that entire circle. I'm going to show you how to draw it on your notes. But r being your radius, theta being your angle. And it is as straightforward as, and like I said, I'm going to show you on this, but then I'm also going to show you how to put it on your notes. So if I have 210 degrees, so I'm going to 210 degrees, which is down here, and I'm going to count 4 rings. 1, 2, 3, 4. That's how you plot a polar coordinate. Okay. So on your notes, what you can do is just draw an X and Y axis and draw your 210 down here and then draw your 4 lines. That's how you can denote it instead of drawing circles over and over and over and over and over again. Okay. So then we can also have a negative radius, okay? If you have a negative radius, you're going to go this exact amount of degrees you need to go to, but instead of counting from the origin out, you'll go backwards. And you would count 1, 2, 3, 4 up this way, okay? So there's going to be multiple ways to say a certain spot on the graph. So let's look at this example. So -4 is our radius, -5 pi over 6. So I'm going to go backwards, -5 pi over 6. So 1/6, 2/6, 3/6, 4/6, 5/6. And then I'm going to go backwards, 1, 2, 3, 4. Okay. That's how you handle a negative radius. So again, on your notes, it would basically be at pi over 6, and then we'd go 1, 2, 3, 4. But we went technically backwards 5 pi over 6. And instead of counting 1, 2, 3, 4 this way, since it was a negative radius, we went the other way. Okay. So go ahead and plot the point to -270. If I go -270 degrees, and my radius is 2, so I count 1, 2. So tomorrow, or not tomorrow, next class, Wednesday, we will be working on a project and you'll be plotting these points. So I wanted to make sure you knew how to plot them. Wasn't there someone in here that asked for the project early?
Yeah.
Okay. I have them printed off. All right, so find 4 different points that get me to where this star is right here. 4 different ordered pairs that get me to that same spot. Oh. So yes, I tried to put up all the testing dates coming up soon. With your test being on Wednesday, y'all are out Tuesday next week. So your test will be on Wednesday to finish that up. So we're gonna do our project this Wednesday, review on Friday, and then it won't fall until the next Wednesday. Remember our state test is the 16th. We will not have 7 a.m. that day. I'll be here if you wanna hang out. But no 7 a.m. that day. And then we'll take our, I called it the final chapter test, but it's the comprehensive final, but it's counting as a chapter test kind of thing. The 20th. And we're done.
A lot of us will be here the 6th or the 10th.
The 6th or the 10th?
Yeah, because we have AP testing.
Yeah, I'll be here too.
With the sticks.
I think by that point, this will be in either reviewing for the state test or reviewing for the final. So
Awesome.
it depends, but that would be it. So it's not new content, is what I'm trying to say. Yeah.
What day are you doing project again?
Wednesday,
Like this Wednesday?
next class. Okay, so what is one ordered pair that will get me to that spot? And then let's go with degrees. If you did degrees.
31,
I'm sorry?
31.
Okay. What's another one?
3 -225.
What's another one? Think negative radius.
Yeah, 30, -45.
3 negative 3 negative 45, is that what you said? And one more?
-3, 315.
Uh-huh. So all 4 of those get us to that star. It's just they have different journeys to get there, okay? So usually you'll have positive, 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 negative, 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 positive, okay? That's kind of how those will work out for you. Okay? So These seem very trivial to draw, but they will actually help us, especially when we're working on converting between polar and rectangular. So if I give you that theta is 180 and to graph it, you would simply just draw a straight line. Okay. That's how you would graph 180. And you'll see here in a minute how that works out to give us that equation of a line. And then if I asked you to graph r equals 2, we would just go to the second ring and we would draw a circle. Just as much if I asked you to draw 45 degrees, you would just draw a straight line going through that way. Okay. So you're just following along those lines and graphing them. And like I said, there's a reason why I'm showing you this before we convert between the two. So we're going to go between having r's and thetas to having x's and y's to r's and thetas, just like we've been doing. Okay. So switching between the two, like I said, we're going to go from having x's and y's to having r's and thetas. So to convert the equation in x and y to polar equation, r and theta, we are going to replace x with r cosine and y with r sine. We used those when we were changing between trig form and rectangular form. We're using them again. Okay, so our first example, we change x to r cosine theta, and then y to r sine theta. All you have left to do now is to get r by itself. So I'm going to factor an r out. And then divide. So r equals 5 over cosine theta plus sine theta. That's a theta in there. It's just not letting me write it. Okay, so we went from having x's and y's to now having r's and thetas. Go ahead and give number 2 a shot. Is the 6th and the 10th the only AP days, or are there others?
That's just AP line and AP push, so most of us will be on that one.
Is anyone out another day?
Yeah. like May 2nd or something like that.
May 2nd, so figure.
Yeah.
Yeah.
May 2nd.
The 2nd, 6th, and 10th. Okay.
And then I think the 5th, but I don't think either.
Do it.
No. There's one other one. I don't know if it's actually reading.
The 5th is a week.
Yeah, not the 5th, so. No, the 5th would be
The 2nd, I won't have you, so the 6th I will. And the 10th I will. And both of those are review days, so. I'll get y'all what you need. So R is equal to 6/3 cosine theta minus sine theta. All you gotta remember is changing X and Y. Okay. So that is just going equations from rectangular to polar. All right. Yeah.
So would it be wrong to just say 2 over cosine theta minus sine theta?
Yes, and here's why. They all three pieces have to be divisible by the same number, bless you, before you can divide them all out. Since that sine theta did not have a 3 or a 6 or any kind of multiple, then you can't divide that out. If it did, you could. All right, so let's look at the coordinates. Good thing. We've already done this, basically, okay? We did it when we were changing trig to rectangular and rectangular to trig form, all right? We're going to plot the point, like we did before. We're going to find R using Pythagorean theorem, and then we're going to find theta. Exactly what we did before, except we plugged it into an equation that was the R cosine theta plus I sine theta. Okay, we found R, we found theta, we plugged it in, called it a day. All right, so now it's almost like we're doing less the work. We're just plugging it into a formula. So keep things in mind. R has to be positive, and you're going to find the smallest theta. What I mean by that is there are infinite answers here. Coterminal angles, you can keep going forever and ever and ever. Just keep the one that's the smallest. Don't be like 700 and something something. Okay, keep within the 360 that we're looking at there. Okay, so let's look at the first example. Like I said, this should be familiar to you. We plot the point -1√3. So right now I have an ordered pair that is X and Y. I need an ordered pair that is R and theta. So I have to find my radius, which is what? 2. You can do it with the square root already, either or. So for my ordered pair, I already have 2. And now I just have to figure out what theta is. And remember, we used which trig function to find theta on the previous problems?
The inverse?
I'm sorry?
Is it the inverse? Okay.
We will use the inverse, yes, but which trig function? Sine, cosine, tangent. Which one has our opposite and adjacent? Tangent. Don't need that. Don't need that. There we go. So then tangent, just like we did when we were changing the forms before. The tangent is root 3 over -1. So like I said, if you're not familiar with your unit circle right now, you can either use your left hand or use your paper plate in front of you. But if I'm going to make tangent root 3, that is a 60-degree reference angle. We'll stick with degrees because that's what we've been doing this whole time. It would be what? 60-degree reference angle in the second quadrant. 120. So again, like I said, we have done this before. We were plugging it into that longer equation. Now we're just finding Rn theta and plugging it into an ordered pair. It's the only thing that's different. Now, for example, the next one, I can't really draw a triangle if I'm on -2, 0. But what's my radius here?
-2.
Be careful.
2.
2, okay. And what degrees are we at? 180. So sometimes just drawing the picture gets you your answer instantly. Okay. We didn't have a triangle to draw. We didn't have any of that nature. So we were just able to go ahead and say, well, our radius was 2. I'm at 180 degrees. Same thing for number 3, but go ahead and try 3 and 4. So if I plot 0, -4, my radius is going to be 4. And what's my degrees? 270. They ask you to do it in radians, do it in radians. Okay, just right now we're just going to do degrees. If I plot the point 1, -1, that puts me over here in the 4th quadrant. So then I would have 1 squared plus 1 squared, which is 2. So the square root of 2 would be my radius. And what would be my degrees? We want tangent to be 1. So 45-degree reference angle in the 4th quadrant is what?
I did -45 with -15.
Positive, what would it be?
15.
Huh?
15.
Uh-huh. Okay. So if you have kind of neglected the unit circle for a little bit, make sure you're bringing it back, especially before the test. Any questions going from rectangular to polar? Okay, let's Let's go the opposite direction. So 4 key equations that we're looking at, ones we've already talked about. X equals r cosine theta. Y equals r sine theta. We've already been using that. R is the square root of x squared plus y squared. And we've already been using tangent of theta is equal to y over x. So again, the little details that I was saying we have done before. You haven't done these problems before, but you've done all of these other little things before. I also write, we're going to need it for the first problem, without the square root taken. So I want the r's and thetas to disappear and the x's and y's to appear, okay? So looking at r equals 3, if I was like we did here, the yellow one, we would have drawn a circle, okay? So keep that in mind. We're going to end up with an equation of a circle that we did at the beginning of this chapter, okay? So looking at r equals 3, I know that I can manipulate this equation, again, so the r's disappear and x's and y's appear, by simply just making r squared. I can square both sides. Mathematically legal that I can do that. Then I can say, well, r squared is the same thing as x squared plus y squared. And that's exactly what that is. That would be a circle with the center 0, 0, and the radius 3. So if I was to draw a circle, it'd be on that third ring, and I would have my graph. Okay? So those are the only equations we can use up there, and those are the only ones we need to use to get these from having r's and thetas to now having x's and y's. So let's look at the next one. Theta is pi over 4. So remember on the last one, or the problem I had you draw the 180 degrees, it ended up being just a straight line. Okay. Well, pi over 4, you graph that as well. It ended up being y equals x. So let's show that. So tangent, my sleeve keeps hitting this over here. Tangent of theta is y over x. Okay. That's information we know. Well, theta is pi over 4. What is tangent at pi over 4? One. Multiply by x on both sides. Exactly what we did. If I was to graph the line 45 degrees, or if I was to graph the line y equals x, they're the same thing. So we're just changing between two different forms here. We're not manipulating it to where it changes the value of any of these problems. Okay. Try these. Keep in mind how to rewrite things like cosecant and secant. That will help you. Just a reminder, grades are due tomorrow. If you have any missing work you want to turn in, I can grade for you. If you have to.
Would you? Okay.
R's and thetas want gone, x's and y's to appear. It's another way to write cosecant. Okay. And if I multiply by sine on both sides, I get r sine theta is equal to 1. What's another way to say r sine theta? Y. Good. Tangent being 3 pi over 4, we're going to use tangent of theta. So tangent of 3 pi over 4 is equal to y over x. So in other words, whenever you're given theta, you're going to use the tangent one. Okay. What is tangent at 3 pi over 4? -1. So y equals -x, which makes sense because 3 pi over 4 is right here. So if I was to continue drawing that line, there's that y equals -x. Now, number 5, I can't just square both sides. But I still want r to be squared. So what can I do? I can't square both sides because that would make it a whole lot more of a mess. But how can I make r squared? Uh-huh. multiply by r on both sides, yes, that becomes a squared, and there's a little r that can sneak in there. So if r squared is x squared plus y squared, and r cosine theta is x, now, we have not been dealing with equations that look like this. We have been completing the square. We're just going to do just that. So go ahead and move that 16x over and complete the square. Oh my word. What's up with the buses? I just got an email saying one bus is going to be an hour and 35 minutes late today. Hour and 30, that's a class.
Yeah, I just skipped school that day.
Behind 2 buses and the garbage truck this morning. I was
Like never getting to school. It's like the worst when they pull out in front of you and you're like, no. So negative 16 divided by 2 is negative 8 squared would give me 64. So then if I factored that out, I get x minus 8 squared plus y squared equals 64. Now, that's an equation we're used to seeing, which is a circle. So we would have the center at 8, 0, and we would have a radius of 8. Okay. So make sure you're completely changing it to the equations we're used to seeing. And number 6, if we change secant to 1 over cosine, multiply by cosine on both sides. Our cosine theta is the same thing as x. So hopefully seeing all the different types of problems kind of gives you a hint that if I see this, I need to try this. Okay. Any questions?
Does this relate to comics at all, or does it?
Yeah, because this is a circle right here.
Okay.
Yeah. So they are actual equations in some sense for both just normal rectangular equations, and then there's some conics ones in there. It does feel like this chapter is very jumpy. Like we went from conics to parametric to this, but all right. So then let's look at the ordered pairs. And that's our last slide too. So we are going from polar to rectangular. Some of these, by graphing them, you can get your answer pretty quickly, but not all the time. So I'm going to show you how to find it both graphically and using the other key equations that we were playing with earlier, okay? So if you look at those 4 key equations, notice how the top 2, we're given r and theta, we want x and y. So what if we used x equals r cosine theta and y equals r sine theta, and we're able to solve for our new x and y? So I take x equals r cosine theta and y equals r sine theta. We can plug in what we know. R is 2, and theta is 3 pi over 2. Trying to put that in there. Sorry. What's cosine at 3 pi over 2? Cosine of 3 pi over 2? Huh? What'd you say? I'm sorry.
0.
0. And what's sine at 3 pi over 2? So then my new ordered pair is just 0, negative 2. If I could multiply. So we just use x equals r cosine theta and y equals r sine theta. Now, in this particular case, we could have saved all that time and plotted that point. And gone to 3 pi over 2 and done a radius of 2. And now I have the point 0, negative 2. So if you can plot it and not have to do all that work, go for it. But I wanted to show you both ways because, for example, number 2, you're not able to do that. All right. Let's go ahead and do 2, 3, and 4. I think that's the earliest I've ever seen them here cut my grass. I'm here later in the day. All right, negative 8 pi over 3. So r, oops. So r cosine pi over 3. What's cosine at pi over 3? Cosine at pi over 3. You have your unit circles in front of you. 1 half. So the first part of our ordered pair is -4. And what is sine at pi over 3? So we get -4√3. Okay, we can plot the point 3, 180 and save us some work here. And have the ordered pair -3, 0. Same thing if you would have plugged it in with the formulas, you would have gotten the same thing. And lastly, if we have -10 cosine of 30 degrees, what's cosine at 30 degrees?
√3/2.
Okay. So we get -5√3 and -10 sine at 30 degrees. Sine at 30 degrees is what?
1/9.
So -5. Okay. So that's how you convert going the other way. All right, any questions?